Okay, Algebra 1 fans, our topic for today, this is notes. We're going to combine a couple of sections here, 5-1, 5-2, and 5-3, solving inequalities. Our objectives after this lesson, we should be able to, 1, solve inequalities using addition, subtraction, multiplication, and division, and 2, create equations from word problems, solve, and graph their solutions. Before we begin, let me give you your joke of the day. What happens when a frog illegally parks? And the answer is it gets towed away. T-O-A-D, towed. So, solving inequalities, basically, we are going to do the same thing that we do when we solve equations. So, in this first set of examples, the directions, solve the following inequalities, graph your solution set on a number line. So, number 1, x plus 3 is greater than 8. Well, just like with an equal sign, the goal is to get the x by itself, get the variable by itself. Now, in this case, the variable is on the left side, so we want to move everything else to the right side. The only thing on the left side with x is a positive 3 plus 3. That is a constant. Now, just like when we solve equations, I'm going to separate the left and the right sides by drawing my line down. To undo addition, we do subtraction. We do minus 3 on both sides. Because 3 minus 3 is 0, so this will be gone. Everything on the left side now that's still here is just x greater than, and this is 8 minus 3, that's positive 5. And that's our answer. X is greater than 5. Now in the book, they write it in set notation, the set of x's such that x is greater than positive 5. Now remember, this is not an equal sign. There's not one answer to this. We have an infinite number of solutions. Any number that's greater than 5 is part of the solution set. So when we graph this, I'm going to draw, here's my number line. Now I'm going to put 0 on there. Always put 0 to separate the negatives from the positives. Positive 5 is somewhere to the right. And let's see, is it open or is it closed? Well, greater than means that 5 itself is not part of the solution. So we're going to put an open circle at 5, and greater than goes to the right. And that's it. That's all we have to do. Number 2, I'll put the number line goes infinitely. Number 2, 2x minus 1 is less than 13. Okay, draw my line down. We move the constant first. We go plus 1. So we get 2x less than 14. Divide by 2. To undo, that's a coefficient. 2 times x, so we divide it. 2 divided by 2 is 1. So we get 1x, which we can just write as x less than positive 7. So the solution set, it's the set of x's such that x is less than positive 7. Okay, that's our answer. I'll put a box around it. Now we have to graph it on the number line. Here's our number line. We'll put a 0 on there. Positive 7 is here. Less than 7 is open, and less than goes to the left. Number 3, x over 4 plus 7 is less than or equal to negative 3. Now the first thing, you're always tempted to move the denominator, but what I'm going to do first is I'm going to move the constant, which is positive 7. So let's go minus 7, both sides. So we are left with x over 4, because 7 minus 7 is 0. This symbol, I just keep bringing it down with me. Less than or equal to negative 3 minus 7 is negative 10. Be careful with subtraction. Now, x divided by 4, to undo that, we are going to multiply both sides by positive 4. The reason we do that is that this is a 4 times x, but then we divide by 4. 4 divided by 4 is 1. So we're left with just 1x, or x less than or equal to negative 40. And so we've got our solution here. The set of x is such that x is less than or equal to negative 40. To graph it, we draw the number line. Here's 0. Now negative 40, I'm not going to count by ones. I'll put negative 40 here in the negative section. Less than or equal to is a closed circle because negative 40 is less than or equal to negative 40, and then we graph everything to the left, less than. So negative 41 is a solution, negative 50 is a solution, negative infinity is a solution. Number 4. Draw the line down, left side, right side. Now this time the variable is on the right side, so I want to move everything else to the left. Let's start with the constant, positive 15. We'll subtract that. That's the additive inverse. 25 minus 15 is 10. 15 minus 15 is 0. So we're left with 4x. And then 4 times x, we divide by 4 to undo that. And we get a decimal. We get 2.5 or 5 over 2. Either answer is good. Now the one thing though that before I graph this, here's 2.5. I need to be careful because when I see the less than symbol, I'm tempted to graph everything to the left. However, notice the variables on the right side. I am going to rewrite this. If 2.5 is less than or equal to x, notice that the mouth, the alligator mouth, is open to the x. So I'm going to say x is greater than or equal to 2.5. All right, it's the same thing. So the solution set is the set of x's such that x is greater than or equal to 2.5. And then I put in closed circle because it's equal to, and then greater than goes to the right. Now, if you're not sure, we can always choose a value and substitute to check. Let's say I choose the number 5. Okay, does 5 actually work? Well, I would go back to here. Remember, the left side is 25. L is the left. The right side is 15 plus 4 times x, which is 5. That's 20. 4 times 5 is 20, plus 15 is 35. Is 25 less than or equal to 35? Yes, that's true. So this is good. This is the side I need to graph to. I need to graph it to the right, to the greater than. Now, you're saying, well, you know, this is actually pretty easy. It's the same thing as an equal sign is when I solve an equation. Yes, with one case that you have to be careful about. Multiplying and dividing by a negative. So 3 is greater than 2. Okay, we know that on a number line. Here's 2 and here's 3. 3 is definitely a larger number than 2. However, let's say we multiply both sides by negative 1. We would get negative 3 and we would get negative 2. Now if we look at our number line, I'll put this in red, negative 3 and negative 2, here's negative 3, here's negative 2. Which one of these is bigger? The larger number is always to the right. Negative 2 is greater than negative 3. Or I could say negative 3 is less than negative 2. Now look at what just happened here. It was 3 is greater than 2, but by multiplying by the negative, I have changed the symbol. The symbol changes because the negative 2 is now greater than negative 3. If I multiply or divide by a negative, I have to change the symbol or switch the symbol. We have to switch or change the inequality symbol. Okay, the less than and the greater than. If I said that 5 is less than or equal to 2. Sorry, 5 is less than or equal to 8, and I divide by negative 2. I would get negative 2.5, and I would get negative 4. Negative 2.5, though, is greater than or equal to negative 4. So when I divide by a negative, what do I do with the symbol? I have to switch it. If I multiply by a negative, what do I have to do with the symbol? I have to switch it. Okay, so let's take 2 more examples here. Number 5, negative 3x is greater than 12. That's negative 3 times x. How do we undo multiplication? We divide both sides by the same thing. We will divide by a negative, but when we divide by a negative, we have to switch the symbol. So we get 1x greater than becomes less than negative 4. X is less than negative 4. So here's 0, here's negative 4. It's open. Less than goes to the left. If I was going to write the solution set, it would be the set of x's such that x is less than negative 4. Now, if I'm not sure, again, if you doubt that this is right, pick a number that's less than negative 4, for example, negative 5. And if I substitute that for x, I would do negative 3 times negative 5, which is 15. Is that greater than 12? Does it make this true? Yes. So that means that we're going in the correct direction when we do the shading. If I had tried 0, however, which is on the other side of 4, if I had tried negative 3 times 0 and said, is that greater than 12? I would get 0, but that's not bigger than a positive number. That's false. So 0 is on the wrong side. My solutions are to the left. Let's do one more here, number 6. Go ahead and pause it and see if you can get the answer to this, and then unpause and see if we agree. First thing I'm going to do is move the constant 5. So subtract it, minus, minus. Now 5 minus 5 is 0, but that leaves us with negative 2x less than or equal to 14. To undo multiplication, we have to divide by negative 2. The reason we divide by the negative is to make this a positive 1x. So that's 1x, but we divided by a negative. So we have to switch the symbol, greater than or equal to, and that's negative 7. So the set of x is such that x is greater than or equal to negative 7. How do we graph it? We draw the number line. Here's 0. Here's negative 7. Greater than or equal to is closed, and greater than goes to the right. Now again, if you want to check, let's pick a number. Let's pick 0. That's easy. If we take 0 and we come back to the original inequality, 5 minus 2 times 0, is that less than or equal to 19? Well, that's 5 minus 0, which is 5. Is 5 less than or equal to 19? Yes, that's true. So to the right of negative 7 is where the true values are. These are the solutions. And that is the end of part 1.